So taking a look at this problem here, we're looking to see when these two equations are at the same point. Now, basically what you're looking at right now, this is something that we could actually go through algebraically, right? Now, it's probably been a while since you've done one like this algebraically, but we could do it algebraically. But we're actually going to go to that algebraic method after we go through some more visualization type methods. And so I'm actually going to approach this by graphing it. We're going to solve this system of equations by graphing. And so this is what you're going to put for your first graphing grid. Now note that this is called a system of equations. Anytime you see this bracket here, it tells you that those equations, however many there are there, usually we'll see 2 for a lot of the work we do, but there can be many more. It just tells us that those equations are connected in some way, and so we call that a system. And that's going to be the theme of what we're heading into right now, is using systems of equations. And you'll notice that it's picking up from the type of graphing that we were just doing in that last unit as well. So we're going to be building on that knowledge. Yes, we just took the test. If you think that means you can just forget everything, nope. We're going to be using that all the way through the year, in fact. All right, so we're going to start by graphing this equation, and then we're going to graph this equation, each separately on the same set of axes. All right. So for that first one, that's our point slope form. Yeah, that's the one that's tricky for most people. The minus 4 here. What does the minus 4 do to our graph? It moves it which way? Up, down, left, or right?
Right.
It's in with x, so it moves it in the x direction. Minus goes right, yeah. So it's going to move right. And then the minus 7, it's over with the y. That tells me that it moves it in the y direction. Specifically, minus 7 is going to move it up. And so I'm going to go right 4, up 7, and plot my first point there. Remember, this is a single point when we're looking at point slope form like this. And from here, I use the slope like normal. My slope is 3, so that means I'm going to go up 3 over 1 and continue that pattern on both sides. All right, and then we'll use a straight edge to draw the line through that first graph. Then we go and graph the second one. So for 2x minus 4, that's slope intercept. That means go down 4 first for our starting point. And then my slope is 2, so that's going to be up 2 over 1. And just keep doing the up 2 over 1. Draw the graph in of both lines from there. This is what you should be looking at. Now that we have the graph of both lines on the same set of axes, we can actually look to answer the question. Because the graph is the tool we use to actually find the solution, but it's not the solution yet. The solution is the point at which they are the same. In other words, the point at which they cross. So I just want to give that point, the coordinates of that point, as my final answer then. So the actual solution then is at 1, negative 2. So having seen the process on that last problem, you're going to know how to do all the rest of these. It's just a matter of practicing and seeing maybe little subtleties that come up along the way. So, on your second graphing grid, write down this system of equations and go ahead and graph them both to find the solution to the system, please. Now, when we graph both of these on the same set of axes, this is what you should be looking at. So our first equation, that's just a line because there's no like absolute value in it or anything like that. And we start by going down 3, and then our slope is 1/3. That means that from that starting point down at negative 3, I'm going up 1 over 3. Up 1, right 3. And then of course for the other one here, the x minus 2 means go right 2. The minus 5 means go down 5. And so that's how we get to our starting point, and then you're graphing your absolute value from there as normal. That's how we get our graph. Now remember, the graph is just the tool we use to get our final solution. The solution is the coordinates of the points where they're actually crossing. Now notice in this case, though, there's 2 of them. So what do we do for our answers? Well, we're just going to list out both of those points individually. So for the first point then, I'm going to call this one the first point. Doesn't matter which one you list first. The coordinates of that point are 0, negative 3. Okay, so that's our first solution. The second solution, I'm going to call this one the second over here. That is at 6, negative 1. There's my two solutions. I'm done. All right, so for solving this system by graphing, again, we're going to graph each of these equations, and then we'll just see where they happen to cross. And so for that first one, okay, hopefully straightforward. The x plus 1, that tells me go left 1. The minus 8, that tells me go down 8. Put my first point there. And then because absolute value, I know it's going to be a V-shaped graph. No problem. The second one, standard form, this is the one where we can't just look at it and know. We actually got to do a little bit of work. So it's a good opportunity to remind us about what that would look like. And so, for instance, I'd plug 0 in for y. And so that would give me 3x, and then the minus 2y, that's just 0. So 3x equals 18, and so I'd find that x equals 6. Now that gives me a point at 6, 0 that I'm going to then go and plot on my graph, right? We do the same kind of thing to find the y value. We plug 0 in for x, so I end up with negative 2y equals 18. I divide both sides by negative 2, and so I have y equals a negative 9. Remember, that also gives me a point. I plugged in 0 for x, and the y was negative 9, so I have 0, negative 9. Now I mentioned this partly because as we now go and solve this, our answer is going to be a couple points. But notice, it's not these points. These points are just ones that we use in order to figure out where the graph would be going through. They are not the solution, or at least not necessarily the solution. When we actually put both graphs together and actually make those, this is what we're looking at. The work we did for that standard form equation was just that. It was just work, not solutions. I come back to that a couple times because every now and then people start getting those mixed up, and I want to help us keep those separated right from the start here. All right, so now I look for the solutions for this particular system, and again I'm looking to see where they cross. In this particular case, they just happen to cross once, and only once, right down here. So my answer here is going to be at 4, negative 3. Please note that if I write it like that, that is listing two separate numbers. By putting the parentheses around it, I'm actually telling us that this is a point, an x and y coordinate pair, otherwise known as an ordered pair. So yes, you do need the parentheses around it. So when graphing these to solve it, again, we're graphing absolute values, so a lot of it we're just reading out of the original equations when we actually make the graph. But before we actually make those, I want to point out one thing on this. The previous problems that we've solved by graphing, technically we actually could also solve them by doing some algebra. Now there's some little tips and tricks that are involved that we're going to be getting into later this year, but we could have done them algebraically. This one, however, where they're both going to be absolute value equations, we aren't going to be seeing how to do that one algebraically. This is partly why I start with the graphing method for solving systems of equations, because this graphing method will always work. No matter what it is, if you can graph it, you can solve that system by making the graphs and just seeing where they cross. The algebraic method, it has some other advantages though, including the fact that you don't have to make a graph. Alright, let's go ahead and actually make these. Of course, for that first one, it's going to be going right 1, and it's going to be going down 5, but the 2. Remember that the 2 out front, when I multiply by it, yes, it is kind of like slope. It works the same way as slope in this particular case. And so it means we're going to go up 2 and over 1 from that starting point. But another thing I want to remind you of, because it's going to be coming into play more and more, because we're going to be getting some other types of graphs here later, is technically that's a vertical stretch. With these V-shaped graphs, because they're straight, we can think of it as slope and it works the same basic way, but it's technically a vertical stretch. So each point is actually going up twice as far as it normally would have. All right, and then same kind of thing with that second equation there. I just want to remind you that the negative out front means your V is opening downward. But that's the only thing it changes. The plus 2, it's still going to be going to the left 2, and the plus 4, it's still going to be going up 4. Neither of those are changed by that negative out. So this is what you should end up with for your graphs. Now when we can see the graphs, then we can see where the solutions are. And again, there's going to be two solutions in this particular case. So that leftmost solution, that would be at negative 3, 3. And the rightmost solution, that one looks like it is over at 3, negative 1. And so I'd give both of those as my solutions.